Okay. View gallery view. Okay, everybody. So today we're going to be talking about backups, file management, and software and version control management, which is basically systems like Git that make it so you can track changes. But more importantly, for our purposes, we mainly want to talk about different ways that we can make sure that that Murphy's Law doesn't really eat us alive. Now, for those of us who don't know, would anybody like to volunteer what Murphy's Law is today?
Anything
that does happen, anything that can happen will happen.
Anything that can go wrong will go wrong. Now, it's just a general, it's not just from Interstellar. Great movie, by the way, but it's just a general principle that to adhere to with engineering. It is attributed to, let's see. It's been, I mean, it's a saying that's been around in some variation like forever. Alfred Holt, before it was called Murphy's Law, it's found that anything that can go wrong at sea generally does go wrong sooner or later. So it is not to be wondered that owners prefer to be safe to the scientific. Sufficient stress can hardly be laid on the advantages of simplicity. Okay. Let's see. So yeah, Edward Murphy after that. But so it's had various things. So in other words, you're working with, and the point being here of why I'm bringing up Murphy's Law is that you're dealing with complex and complicated machines that have had their had a nice UI thrown on top of them, and made very nice and easy to use for some definitions of easy. But point is that we've got these nice layers of abstraction between you and the physical bits and also the hardware. And every step of the way, something is probably going wrong right now. You've got a bunch of hard disks, you've got RAM that could fail, you've got motherboards, you've got a CPU that might have an issue with it. You could Windows operating system, the Mac operating system, the Mac OS operating system, the Linux operating system, all of them have some kind of bug in it, if for no other reason than they're using a free open source library that is supposedly been reviewed by people, but nobody's bothered doing a code review because that's boring, right? Bugs are everywhere. And the only reason that basically things tend to keep working is because a lot of systems have fail safes in place, or that the bugs just are super rare, so they don't show up too often. Part of it's also in my particular domain of distributed hash tables, when I was doing research as a PhD student, we were working on getting on a system called Cord, which was like one of the first distributed hash tables out there, and it was very well studied and stuff and published and stuff like that. But we could never get it quite to work as specified in the original paper because we had to tweak it. It turns out the original paper had a bug that just kind of went unreported for 10 years because people thought they were just weren't smart enough to understand what was going on with the paper. Me being a PhD student thought these guys are good. I must be missing something, So bugs occur everywhere. And I haven't even approached the most awful part of using a computer, which is computers are useless unless you have people working on them, and people are awful. They really are. They drop things, they spill soda or coffee or water on equipment. They
clean their
they
computer.
drop it. They download viruses and run them. They're awful. Humans are awful. at least in the context of computer usage. In fact, the best way to keep the computer bug free is to just keep all humans away from it at all times, or possibly keep it turned off and encased in a concrete shell underwater. Then maybe we might be able to keep it bug free at that point. So, point being is that you should have contingencies in place if your computer breaks. Now, you don't necessarily need to be as backup plan focused as I am. I got asked once how many computers I have, and I forgot to, and I was having trouble counting. But I have my laptop. Sorry, I have the desktop I'm working on right now, Amerlin. I have my laptop. So I have my work laptop. Sorry, I have my work laptop. I have my old laptop, my 2018 laptop that I gave to my wife. I have the laptop that I used from grad school that I bought in, oh God, when did I buy that? Well, the laptop was built in 2013, so or 2012, so it's pretty old at this point, but it still works for watching TV and stuff. And then I have my wife's desktop hooked up to the TV upstairs. So we do have a lot of laptops, computers that, because I just don't throw them away, and I built them right and they keep working. So yeah. But we're not talking about like having multiple systems here. That's expensive, and you may not be able to do that. We're talking about basically, okay, I've got my source code here, and my computer and my brother decided to spill soda on my computer because my brother's horrible, or my sister decided to download this program and run it, and now my computer wants me to pay some Russian hacker $20,000 in Bitcoin to get all my data back, right? So backups are important. So first off, let's talk about the simple backup processes that we have that are not necessarily unique to programmers, right? So what are the cloud storage resources you have access to as Temple students? Yep. Mega. But specifically, yeah, there's Google Drive and OneDrive. I don't think Mega is necessarily a Temple thing. So, but you've got Google Drive through the education platform. That's in transition, but at least for the next year, you should still have like close to unlimited storage there. With Microsoft's OneDrive, you have a terabyte of storage, which is basically kind of the standard hard drive size, which you can purchase for now like $40, which is kind of $30-40, which is kind of amazing. As long as you have a decent internet connection, just be, you should definitely throw basically all your files onto like a cloud backup if you can. It's very reliable. I don't necessarily think you lose it after being a Temple, but you'll have to look up those policies. I think with Google, right, those benefit at least until they change things next year. You don't lose that kind of stuff. But again, check their policies. But so those kind of things are good because they just automatically back up. You can either download an app to automatically back up your stuff, or you can do what I do and just drag the relevant folder on occasionally. But you might decide, okay, I'm going to do a lot. And, these days you might start, if you're working in a Chromebook, especially, you might be doing a lot of your document writing online anyway. But what about like for programming, right? So in programming is a bit different because it's something that has a lot of, you work on a file that has a lot of changes. You can have different versions of programs, and, you might go down a path, try to add a feature and decide that's a terrible idea, and let's not do that. And you might want to revert those changes. Meanwhile, you might have another member of the same project working on other features that do get implemented, and that gets brought back into the full project. And meanwhile, there's other stuff being added. So it ends up like looking like this kind of tree of work that just kind of goes out and goes back into each other. There's different, and what software is used for this is called version control, and it has some really nice, cool math that I'm not going to get into because math is scary for a lot of people and boring for even more people. So but there's some cool graph theory behind it. But anyway, but saying there's cool graph theory behind something is like saying that things are made of atoms. You know, you find that graph theory if you go looking for it. So anyway, let's talk about one particular dude. I say this dude because specifically he's the guy who made it. Let's look at this. Who's this man? Linus Torvald. Oh, I need to share my screen. Right? Let me share my screen. Linus Torvalds, a Finnish American software engineer who's the creator and historically the main developer of the Linux kernel. Kernel, as you might imagine, being kind of like the core bit of the Linux operating system. What is the Linux operating system? Linux operating system is the operating system that about 2/3 of the web, I think, runs on, 2/3 of servers. It is a free operating system. I think he's laughing. He did step back for a while on the email chain to deal with his anger management issues. But he is but anyway, he developed Linux. Now, Linux is a free operating system, specifically free as in gratis, and free as in libre is what they say. Free as in basically that you have the freedom to modify it as you wish. You can see the source code, and free as in you don't have to pay anything for it. Free as in the phrase that often gets passed around is that free software is free as in speech and free as in beer. So that is kind of the idea that they use there. But so anyway, already made a huge contribution with the Linux kernel, which is this core of the operating system, Linux, which has tons of distributions. Big fan of Linux. If it wasn't for the fact that I have a lot of audio software right now, and I don't want to try to mess with my computer during a very busy semester, I might be I'd be tempted to run Linux. Right now, the only thing I can't reliably use on Linux that I really need to is this thing, which is a VR headset, right? As the only thing that really I can't run on Linux right now. And I've looked into solutions that let me do Linux and Windows at the same time, and they're all just so complicated, overcomplicated. So yeah, that's why I'm on Windows. But anyway, so the other thing he's done is that he also controlled the distributed revision control system Git. Now he likes to name things after himself. Linus, Linux, right? But so he's also joked that he named Git after himself, which is oh yeah, totally. You can totally run two operating systems on the same computer. There's different ways of doing it. You can load one at a time in a process. You can load one when you decide to boot up in a process called dual booting. You can also, the other process is virtualization, where you can have your main operating system, and you can have the other operating system in a virtual machine. And then the other thing you can do is you can do something like a hypervisor, where you have a minimally kind of minimal overhead system, and you can run multiple virtual machines at the same time and give them access. But if you're not running Linus Tech Tips has a number of videos of basically like having a single computer being serving multiple people, like 8 computers in one machine. It's pretty cool. And he goes through on how to build those things. But anyway, so what is Git? It is a software to track any set of files and how they change. So basically, what happens with Git is that you commit your files to Git and basically you upload them and then it tracks the changes. So let me go ahead and basically you could do that on your own computer, but what's usually very helpful is that you have it stored somewhere online. The most popular place by far to store things using Git is GitHub, which got bought by Microsoft, I think like last year or 2 years ago. It got bought by Microsoft, which was a very good choice on Microsoft's part. So I'll go ahead and sign in. They're going to ask me for my two-factor authentication. 1, 2, 3, 4, 5. That's the same combination that's on my luggage. Anyway, let's keep the discussion relevant in the peanut gallery and try not to throw random insults on at anyone else, shall we? Oh, right. No, I don't. I'm not waiting for a text message. I'm using the Authenticator app. That's right. So I highly recommend doing two-factor authentication to anyone who is to anybody who has stuff online. Do two-factor authentication. So what I did is that I used to track a lot of stuff on GitHub, mainly so that I could see, like, here's my profile, and I could see when I was committing stuff. Like when I was a lot more active when I was actually like working on my dissertation. So this allowed me to keep a track of like when I was doing my work and stuff. There's me, there's my dog. She's so much younger. There's like no white on her nose. Like she's got an all white. So anyway, this is my whatchamacallit, my GitHub page where I've got my private repositories and my public repositories. My private repositories are just simply stuff like, you know, let's say this one, which is basically where I create my assignments and my exams and keep them loaded up. So I think I was in my late 20s in that picture. So, and then we've got our classroom. And so then I've got my classroom and my thesis. My thesis is possibly probably the most interesting one because I've got a lot of paper that I've got this is where I did my dissertation work. And what you can see here, what's cool about this is that notice that there are 356 commits. Commits being basically anytime that I or somebody else did some work on it. So after I started on the dissertation, I have had some help with basically creating some presentations. And so I had other people do that. But here I have making comments, and each of these I can tag and see basically the changes that I made to my document, to this code, because this document is code as I go through. So it's a very useful thing for these kind of process. But more importantly, I can just kind of load it up anywhere. So for instance, I'm just going to go to CD user. So I'm going to go to CD users, Andrew, desktop. So I'm going to go ahead and I'm just going to load this up onto my desktop just from the internet. Git clone. I'm going to clone the repository is what is the terminal for the terminology. Now I'm going to be using the terminal for this, but as I'll show you, there's no need to use the terminal. You have no need to use the terminal for this. You can instead use a desktop app very easily by going for this. And GitHub is free, by the way. It's free to use. So Git clone, and you don't really sign off any rights of ownership on this kind of stuff. Git user, so Git clone, and then I just need the repository name. So thesis, which you could go to over here and say, hey, okay, this is and copy this, but I'll just go ahead and type it out because Git clone https:// www.github.com/ AB Rosen, which is my username, and this was thesis.git. Parameter cannot, what am I missing? Set location. Positional argument. Hold on a second. Oh. I jumped the gun there. CD there. Now do git clone. In the middle, I never actually changed directories to go there. Git clone. That's hilarious. After this class, you should probably, yes, GitHub is where you're going to be wanting to upload your stuff on the final project. It really doesn't add much overhead, as you'll see. So here, basically, boom, it is now running, and it is currently downloading the 40 megabytes that project is. And now if you go to if I go to my desktop, here's the thesis folder that literally just got, and went open to the other screen. It literally just got loaded here. Literally created today at 2:24. Yeah, after this class, you'll want to make yourself a GitHub account. So, or Bitbucket if you want to do that service, that's fine. But anywhere to store code on Git, you know, you want to do version control. So let's go ahead and create a repository. So I'm going to show you basically how this works. So let's go ahead, and I've got demo CIS 1021. I'm going to go ahead and delete this. Notice that delete is in what they call the danger zone. Final project is due the very last day of class. Once you delete this repository, there's no going back. Please be certain. Click delete. Unexpected bad things will happen if you don't. This cannot be done undone. Please type AB Rosen. I really appreciate that they make me have to jump through hoops to make sure I delete it. You know. There we go. Hope that wasn't important. Okay, so new. So I'm going to go ahead and, so to create a new repository, it's very simple on GitHub. To create a new project, very, very simple. Okay, you just do this. And again, you can do this on any kind of, it's not just GitHub that you can get projects on, but GitHub is by far the easiest and most popular. I'm going to go ahead and call it CIS 1051 demo, and all it does has to do, it only has to be unique for you, so that's fine. Description: how to use Git. Okay, so public, anybody under the internet can see it. I can choose who can commit, which in other words means who can contribute to it, and then skip this repository if you're important. So I'll go ahead and add a README file, which will create a blank README file. Okay, and then there's licenses as well, which who can do what with your code. In general, I'm going to go ahead and just select the MIT license, which simply says, and if you don't know about licenses, spend a couple minutes on this and see what it does. MIT license says anybody can use what I'm writing here for anything, but if it blows up your computer, it's not my fault. So create repository. So that's it. And then I can either, there's two ways you can set this repository up, which is that you can use the command line and basically git clone, and wherever I want it. And there. So I could just simply, and it's on the, it's now currently on my computer and on this main branch on the server. Or as you can see here, I could click setup in desktop, but I don't think I have that. So if you want an app to basically handle all that stuff for you, you can do desktop.github.com, and it will redirect you to the appropriate. Oh, are you using Mac or Windows? If you're using Linux, it assumes you know what you're doing and you should use the command line. I use the command line almost entirely on this because the commands are fairly simple, but let's go ahead and download this sucker. Desktop, we're going to go ahead and run it. And that's it. That's all you need to kind of set up a version control management. GitHub desktop is being installed. It will launch when it's done. Okay, while that's going on, we can see over here that our GitHub repository has that our Git that what we have here has two files, a license file and a readme.md file. MD is short for Markdown, which is it's like text. It's like slightly more advanced than a .txt file. It's not particularly exciting. I'll get into it in a second, but also over here, now that we are over here, right, I can go to my repository and see, hey, the same file, license and readme, which had CIS 1051 demo, how to use Git, and the README file over here, CIS 1051 demo, how to use Git, they match. Markdown, this is how you make a title, like a big section. So what I can do now is how to use Git. A README file. So this way people know about your project. I'm not really sure when you said what you mean doesn't have any columns or cards. Did you start a new repo in GitHub?
I started a new project and I don't have a repository. I don't know. It just says this.
You want to start a repository.
Okay.
So go to your, if you're here, go to repositories and click create new repository, or go over to here, or go over to the main page and click repositories new. Repository, not project.
Okay.
So I'll name that over here so that I didn't realize they had something separate for projects that was called projects, and that might cause confusion. Anyway, so I've saved it here, but it's not been uploaded to GitHub. Yep, configure Git and email. Okay. So I will get into the GitHub client later. Right now, I want to kind of show that basically that how does this work now? So now I'm going to go ahead and CD into the folder with all the stuff here. CD 1051 CIS 1051 demo. That just simply so basically I'm in the folder. It has the license. It has the README. Can I do VI? Yes, I have VI. Great. No, I don't have VI. Great. About Vim? No. Nano. No. No, that didn't do anything I wanted it to do. Okay, great. So anyway, let's go ahead. But anyway, we're in this file, in this folder right now with this file. The file has been changed. So the first thing we want to do to track a change, to basically save it, or rather to super save it as a snapshot, is we run a command called commit. Git commit. Git, because that's the program we're using, commit, and then the file name, which is README. Now it's saying, hey, can you please edit the file? Please tell me what's the changes. Added explanation of creating a README file. Explanation. Okay. And then the next step is Git push to upload it. So committing it basically says this is the snapshot I want to save. Push means please upload it to the server. or to wherever it's being tracked. Now it will ask you for your username or password unless it's already stored on the computer, in which case it is for me. And now if we go back to our project over here, right? I go back over here and it says, hey, okay, the license was created 6 minutes ago, but ooh, this commit was created 1 minute ago. And look, the file changed. So if we go now to commits, we can see that basically that we had the initial creation and we had this. So that was pretty cool. Now, mind you, you can work on stuff in GitHub or on another computer, right? You could work on another computer. So let's pretend that some other change has been made on another computer. Like over here, I can take this file, readme.read, this readme file. Sorry, let me go over here, click on the file. And now I can basically say here, edit this file, pretend this is being done on a separate computer because technically it is, it's on a computer on the internet, right? So how to use Git. Subsection. You split things into sections and subsections. You will seem organized, and that you will seem organized and that you know what you are doing, right? So I'm going to go ahead and basically make the changes right here. Not going to bother adding a special comment. Commit changes. Great. So I've edited the file on another computer. Let's just pretend it got uploaded from a different computer here, because multiple people can be working on the same project, especially if you're, so that can happen. Let me go ahead and show you. So let's say I'm working on my computer at home. I pick up my laptop. I pull the latest changes. I make some changes on my laptop. And now that I'm home, I want to work on my computer after I've uploaded all the stuff, right? Because we know how to upload stuff. I uploaded before I went to my laptop, then I downloaded, which is the step I'm going to show you how to do. Then I make more changes and they can download to my other computer. So I can always just simply get the latest changes by doing git pull, right? You push to put stuff onto your main server. You pull to get it off, and it will just make the changes. It will just download the changes and make them on your computer. And remember, nothing's ever permanently changed because you can get it back onto your computer, because you can always revert, which is a bit more complicated than what we need. We don't need to learn how to time travel, but it will always track the changes. So let's go ahead and do this. So over here, I'm going to do subsection. Okay. Okay, I'm gonna save this over here. Git commit -a subsection A. This is a subsection, I guess. Okay, and then we can save this and commit it. And this is where it really shines, by the way. Added a subsection. Hit push. Okay, so now I've uploaded that change over here. Let's go ahead and do another one, because I didn't mean to push. Okay. So I'm going to save. Okay. And then I'm going to commit this over here. Added a second subsection. Now, we won't be working in this too much in this UI too much longer, but I'm trying to show you how to do it. Yes, you can commit multiple files at once. In fact, I'll show you how to do that in a minute. and how to add files, because right now I'm just modifying files that we already have. So I've committed this file. Now let's go back onto the web. Okay, because I'm trying to limit the number of commands we're learning, right? So readme. So here we've got subsection A. Now suppose that we're two people, Alice and Bob. Alice just wrote this part over here, and she's about to upload it. Meanwhile, Bob is doing his own work and he's adding another section to this document and saying section B. This is another big section. Files can sometimes create conflicts. So let's go ahead and commit that change and already upload this. So I've committed. So now Alice goes with her work and she's typing and she's going, great. Okay, I've done my work. So I'm going to go ahead and push. And she gets an error. It says error, failed to push some references. And then hint, updates were rejected because the remote, in other words, the server, contains work you do not have locally. What does that mean? This usually is caused by another repository pushing to the same ref. You may want to first integrate the remote changes, e.g. git pull, before pushing again. In other words, it's saying, you know, that they did some work before you did. The work you've done was not using the latest copy of the work. So we're going to try to merge these things automatically. But before you can upload, you have to have the latest version. So you need to pull. Git pull. And it says, hey, we tried to auto merge conflict. The merge conflict failed. Try to fix the conflict. So manually fix that and then commit the results, which is no problem. So we just open our markdown file again. And it says, hey, the head, which is what we're doing, has this. And B, you know, these are so here we had, you know, on our computer, we had this. And on the server, we had this. That's what this is saying. And saying, please rectify this. And I'm saying, okay. And by the way, it's giving me options over here to what to do. I'm just going to go ahead and actually say, you know what? They both are fine. I'm going to keep them all. And going to save this file. I'm going to say git commit. And I'm going to say, hey, I'm good with what we have. We've merged. And git push. And now everything is fixed. Okay, but how do I add some files to this thing now? All I did was just simply change the file by removing the text that was there. That, right, we had this. After it couldn't figure out what to do. A lot of times it's actually very good at figuring out what to do. Like this. So let's go ahead and create a new file, by the way. Git add. So first thing, let's go ahead and actually, to make a new file, you have to have a, let's first make a new file in here. So new file. Let's just make a silly hello world. It doesn't matter what the type is. I'm going to erase it anyway. It's not actually a doc file. There's no data in it. So I'm going to say it's a hello.py. Yes, I want to change it. Now it's a Python file. Because it's empty, it doesn't matter. So let's go ahead, print hello. Yes, I know how to use Python, don't worry. Okay, save. And we won't keep this, don't save on this right now because I was simply undoing to show you stuff. So here we've got a file. So that if I try to commit it, it won't be detected because Git doesn't know to track that file. You have to tell Git the files you want to track. So git add hello.py. Suppose actually, so that would add that hello.py. And now it will track it. And so I can say git commit and says, hey, here's a new file to track. Hello world in Python. Git push. And now we check our repository. It's over here in Python. Hello world in Python. Great. So let's do ahead. So let's go ahead and do another conflict that we had. This time we're going to make it easier to change. Over here, I'm changing the hello to hello exclamation point, you know. Added some enthusiasm. Assuming I spelled that wrong, whatever. Okay. And now I'm going to go ahead and add the second line of hello world, which is print world. Right. Save. So we are going to go ahead and git commit. So it says, what did you want to, now if you just simply say git commit, it's going to ask you, wait, which file did you want to change? And I say, hey, okay, I want to change git commit hello.py. That is the file I wanted to change. I wanted to I want to say this change, please make a snapshot of it. If you're being lazy, which I am almost all the time, you can just simply use git commit -a to commit everything. That means all the files. So added world. Now, again, we have on our server, that's more up to date. So we're going to get a conflict when we try to push. Git. So git pull. And it says, hey, you've got a conflict again, right? Because it can't, it simply says you've got hello and world. So now again, we've got to figure out what do we need to do. So what kind of changes are automatic? Because most of these changes, this kind of change isn't. So I'm just going to go ahead and in that. Generally, if you're the only one working on it, it's pretty easy to figure out. Merges are the worst. They're the hardest part of using Git, but they're not hard because of Git. They're hard because people are silly. So git commit, right? Merge that branch. Okay. And git push. So let's see one more example of something that would be able to be taken care of. So print begin hello world. Okay, save. So we're going to save and we are going to commit that without pushing it. And then we're going to stop with the command line stuff. Git commit. Oh, right. I need a message. Added begin. Git. Oh, no pushing yet. Okay. And now we're going to go ahead, refresh this, right? See, it's been accepted change. And we're going to simply say, at the bottom here, I'm going to go print end hello world. Now say that this is actually a very common kind of change where you might be working on a function up here, or you're over here. You'd be doing, so when you're doing your final project, you should be uploading it to GitHub as you're working on it. You should be backing it up to GitHub. So commit changes. This has been over here. So now again, when I push, I have to, it says, change has already been made. Git pull. It says automatic merge failed. Really? Git turning me into a liar here. Okay, and it says, hey, you've got this. And again, we're just simply going to accept both changes there. Because it wasn't sure which one I wanted to do. If on the other hand, you're basically working on different functions, like basically you have multiple functions you're working on and everybody's working on it, different functions and changing different functions, it generally is good at telling the kind of when it comes to functions and splitting things up into functions, how to automatically merge stuff, I think. Git commit. Unresolved conflict. What? Thought I'd resolved the conflicts. Git commit -a, right? commit all. Okay. So, okay, that seemed, but it's got a command line. That seems really hard. So let's stop looking at the command line and, okay, I've downloaded the app. I installed it. So I can, let's go ahead and right now I'm going to delete this work over here, pretend I'm on a different computer, right? So what am I going to do? I'm going to go ahead and clone a repository from the internet. Sign in, continue with browser. Yep, okay, ta-da, right? It identified me, no worries. All right, so suppose you basically start up your repository in GitHub. Then you can just simply select it from here. Let's go ahead and give me 1 second. File, edit, options, appearance. Well, first off, switch to the theme, but okay, first off, Windows Terminal for the shell, but I was hoping to make it bigger. But anyway, here you can see the one we've created earlier, and I'll just click it and say clone. And it will go ahead and do all the downloading that we'd already done. And there, boom. So where is this file anyway? Where did you put it? Let me double check where you put it. It's in one of two places. I think you put it in a place I didn't. Yeah. So if you go to my documents, after using that, if you go to my documents, there'll be a new folder called GitHub, and anything you've downloaded will be put there. So there's the Git file. Oh, that's 1051 demo. That's not the one we want. Let's go ahead and clone a different repository. Choose. We were doing CIS 1051 demo. That was that one. Clone. Boom. Done. If it's not your repository, by the way, and somebody else's, you can clone it as well. Part of being on GitHub is you can fork somebody's changes. So anyway, it says no local changes. The history. Here's the history of all the changes that have been happening. It's actually quite small, and that's rather annoying. Anyway, main branch. Branches are basically when you're adding features. Right now, it's okay to work in the main branch. So open your repository in an external editor. Here, it's automatically integrated with Visual Studio Code, and it just loads up like, here's your hello, and here's the license that we downloaded, and here's the README file that we used. So that's great. Okay. I want to make more changes. Section C. Oh, fancy. A third section. All right, I'm going to save this. Right. Notice also a lot of editors like Visual Studio Code in PyCharm, a lot of them have GitHub integrations, and notice we're in a Git folder, and that you might want to make changes. I can like hit this button. This action will push and pull commits from origin.main. So I could do this all from the editor, because a ton of editors these days have GitHub integration. You can just do that, but assuming you don't, because you're working in idle. Okay, I've changed the file. Oh, look, it's detected that I've changed a file, right? Let's go ahead and add our comment. Added a third section. Always good to add a comment. And now, rather than using the command line to do git commit and then git push, I can just simply hit this button, commit to main, and then I could make more commits, right? Like this. And another line. Save the file. It says, oh, okay. I know it's very tiny. Here I'm committing a second. You can push as many. Oh, you can totally do this in idle. You can totally do this in idle. I'm sorry. No, this is the GitHub, but what I was saying over here with Visual Studio Code and other editors is that there is GitHub integration built in. Like if you glance really far down here, it says it's got 0 down arrow, 2 up arrow. It knows that we have 2 pending commits to push, right? It is integrated with Git over here. It knows how Git works, and it knows that, how to work with GitHub. So you can do it all from Visual Studio Code, but assuming that's not what you want to do, right? You can just use this thing over here if you're working with GitHub and make your commits, however many commits, and then when you're ready to push, you just hit the button and now your code's on the internet. So this has basically changed everything to, make it work on the internet. Okay, so now let's go ahead and do some changes on the internet and see how that works over here. So, I'm going to change this file. I'm going to add a comment at the top. This is a hello world file. It is boring. Okay, add a space here. Okay. Added documentation. Okay, so commit changes, boom, right? It's already now uploaded there. Let's go to our repository over here. It says no local changes. So let's go ahead and, okay, so periodically it will check, but let's go ahead and hit this. And this says fetch origin. It basically looks at the repository on the internet and says, hey, has there been any changes? It says, yes, there has been changes. Do you want these changes? And so remember where we had to commit. So remember where we had to check for commands and stuff, or say you're working with somebody else and they said, okay, I've uploaded this stuff. You want to get the latest copy? You hit this button to refresh and see what changes there have been. And me doing that again just simply was the same as hitting the button, apparently. So it pulled the changes. So now I open up this file and it says, hey, there's the comment that we had previously. So that's pretty cool. So this has basically been reduced to a button pushing process. Again, the hardest thing has been basically that so the hardest thing that you sometimes deal with is when you have something like this. I made a change here, okay, and then let's go ahead and commit this, and then I go and then over here, edit, and another okay. Okay, and so now we've got this. And so now if I try to push, it says unable to push because there's commits on the remote. So let's go get the commits from the remote. Let's go ahead and pull from the remote. So this was pull. And now it says, you can just push, because guess what it did? History, merge branch. It automatically merged. These two things. It said, I know how to merge these two changes because you added a line on your computer. You added this line over here in between all this other blocks of stuff. And on the server, you made this line over here, or maybe it was the other way around. The point is, it knew how to automatically merge them. So both the changes automatically got merged and we're back to working. Worst case scenario, if you get into a state where you can't fix things, XKCD has an excellent comic about what to do in this case. Okay. One second. So this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them to sync up. If you get errors, save your work somewhere else, delete the project, and download a fresh copy. All right. So how do I commit changes directly from here? Let's see. And another. So go ahead. I'm making another change here. Save. So I can pretty much hit this button down here, I think. It says this will push and pull. Okay. Would you like code to periodically run git fetch? Nope. Okay, and then it says, let's see, select the ref to check out. I don't know, main. Let's see. I'm not really sure how to commit from this, actually. I know you can. I'm pretty sure you can. But I'm not really sure. I never use. You gotta understand. I don't know how to use it from Git Commit. I don't know how to do it in Visual Studio Code. I'm pretty sure you can. Could be wrong, even though I said like with super certainty earlier. Could be wrong, but I'm pretty sure. I don't typically use this web app. Typically, when I'm making changes, I use the terminal to do everything. But in a nutshell, this is Git and how you use it. And now your code is saved somewhere. And basically, it is a big way to make your portfolio of stuff. So for instance, like all my homework over here from my network security class is on here. Like here's the here's one of the homework documents I had to do. Let's see, homework 2, where basically I wrote up my answers for that class. Which makes it sound honestly, and it makes me look a lot smarter than I actually am, which is cool. So, similarly with my numerical analysis homework, I was doing that over here. Numerical analysis. Yeah, numerical analysis homework. So here, right here were a couple things where I had to do for math homework for numerical analysis, where I was working on where I did my code in Python, and his only requirement is that he had to be able to run it on his computer. And so I just added in the comment what kind of Python to use. You gotta love my my comments over here. For blah and blahs, print blah. Now this is actually in Python 2.3.7, so you didn't have to have parentheses around the print, which ended up being a change they made because they wanted to make sure that you knew print was a function. And then lambda expressions. Oh, but this is cool. Watch, I've got Newton over here. That's a function in here. I can click on that and it says, hey, that's in line 24. You can go to that. So it does actually like read things in your file, which is really nice. That's really nice. Is it really 8 years ago? Geez. Okay. So here's somebody else's project, Python Snex, which is a project for Python curriculum. I helped commit. I made a small pull request on that one to fix an error there. A pull request is basically on a big project where somebody makes a suggestion and you say, these are the changes I would want to make, but it's your project. And they go, okay, I'm going to integrate it. Similarly, Advent of Code, that was for doing a lot of stuff. Notes is a lot of other stuff I have. But I mean, like I kept a lot of stuff on GitHub to do a lot of projects. And again, it's really helpful. Like if I'm trying to set up a new computer and things break, I can just simply get up a new computer. I can get working with a new computer pretty quickly, which is very useful. Now again, so anyway, let's talk about your homework for the week, which actually is going to be which should be fairly straightforward. Right. No, I don't want the grade book, and I certainly don't want to share the screen of the grade book. That'd be a major FERPA violation. That'd be, bleh. It could be a whole can of headaches. Okay. Oh yeah, I want to go to So yeah, let me grab this. So screen share, screen 1, and let's drag this over. So proposal in GitHub Lab. So in this lab, we are going to brainstorm for our final project and think about various options. I've taken the steps of the final project from CS50 to use their words. Intended to promote early thought, the proposal is your opportunity to bounce one or more ideas off of the staff. If collaborating with one or two of your classmates, each of you should submit a proposal, even if it's identical. You'll notice we don't include a Dropbox for this assignment. Instead, we want you to create a GitHub account, create a repository, and host your document there. Refer back to Tuesday's lecture. Well, today, Thursday's lecture. So let's go ahead and edit that, which I will upload. This is well with Tuesdays. Thursday's lecture. Okay. And here's the proposal file. It is a .md file, which you'll want to open with a text editor. MD is for Markdown. It is a text file. Okay. And you just simply edit it. If in doubt, you can probably open it in idle. Using the open and then selecting any file. But if you can't do that, then there's your computer has a text editor in it. It will be able to open it. So basically, we just want you to fill this out and upload it to your GitHub repository, to your GitHub final project repository. Okay. And then what you do to submit your project is let's go to student view. You hit submit assignment, and then you just put in the URL of your project. Now make sure that it is a public repository, not a private repository. If it's private, I won't be able to see it, which means that I won't be able to see that you submitted anything, which means a 0. So, right. So here I would just simply do, here, what I would do is to submit it again, I would just simply go here, hit submit assignment, and then, okay, let's go ahead and do, right, here is let's assume I put my proposal on here. What we'll want to do is just simply hit this and hit submit assignment. Boom. Okay, and there. And then submission details, right? It will load this, and then I'll be able to click on this and get to it. So that's all you have to do for this week. It's a very simple assignment. But it does, so conceptually it's very simple. It does necessitate you learning a new tool, which may take you an hour to do. But it's not like this should not make you bang your head against the wall in frustration. If it is, please let me know. Yeah, learning, right? If it is, please let me know. All right, with that, I think I'm done with today's lecture.